In the quiet, patient world of astrophysics, where light from distant epochs finally reaches our waiting instruments, a fundamental truth has long guided our understanding. No two galaxies are alike. Each grand spiral, each chaotic elliptical, each tiny irregular whisper of stars carries its own unique cosmic fingerprint. They might share broad characteristics, certainly, but their intricate details, their precise arrangements of starlight and dust, are as individual as snowflakes. This rule, this elegant diversity, was an accepted rhythm of the universe. Until, that is, 2013. Imagine, for a moment, the hushed anticipation in an observatory control room. Screens glow with faint, distant light, revealing secrets billions of years old. And then, a gasp. A dataset appears, showcasing a pair of galaxies. Not just any pair, but two breathtakingly identical spiral galaxies, their arms swirling with uncanny precision, their central bulges mirroring each other with a fidelity that seemed utterly impossible. And stranger still, they weren't separated by vast cosmic distances that might explain some obscure evolutionary path. No, they sat right next to each other, so close it was immediately, startlingly obvious they were freakishly similar. This impossible duo became known as Hamilton's object. The initial reaction was a blend of awe and deep, gnawing perplexity. Scientists, poring over the images, ran simulations, checked and rechecked their data. How could this be? If no two galaxies are alike, how could these two exist side by side, perfect doppelgangers? It flew in the face of everything understood about galactic formation and evolution. Theories were proposed and swiftly discarded, each one failing to adequately explain the sheer baffling coincidence of such perfect replication. Was it a rare, bizarre cosmic accident? Had a single galaxy somehow fissioned cleanly, precisely into two identical halves? The prevailing consensus remained. It simply didn't make sense. The universe, it seemed, had thrown a curveball so wild, so improbable, that it defied all known rules of play. For 2 years, Hamilton's object remained an enigma, a cosmic riddle etched in starlight, a testament to the universe's capacity for surprise. Then, in 2015, a new suggestion emerged, a theory so audacious, so bonkers, that it had initially been dismissed by many as too far-fetched. The idea? Gravitational lensing. Now, gravitational lensing is one of those phenomena that truly bends the mind, not just metaphorically, but literally. Albert Einstein, in his profound theories of relativity, predicted that massive objects, like galaxies or clusters of galaxies, could warp the fabric of space-time around them. Think of a bowling ball placed on a stretched rubber sheet. It creates a depression. Now imagine light, normally traveling in straight lines, encountering this cosmic depression. Instead of continuing its linear path, the light is curved, bent by the gravity of the massive object. This curvature of light can have truly astonishing effects from our perspective on Earth. When a large celestial body, acting like a cosmic lens, perfectly aligns between us and a more distant object, it can actually bend the light from that distant source in such a way that it appears closer than it really is. And, even more fascinatingly, it can create multiple images of the same object. It's like looking through a distorted pane of glass or a funhouse mirror, where a single reflection can appear as two or even more identical copies, seemingly sitting side by side. These are cosmic mirages, illusions woven from the very fabric of space-time. Could Hamilton's object, this impossible pair, be just such an illusion? When researchers turned their powerful instruments and their keen minds back to the precise celestial alignment that might be causing this effect, they made a remarkable discovery. Between Earth and the twin galaxies, perfectly positioned to act as a cosmic magnifying glass and mirror, sat a truly colossal cluster of galaxies. This massive cluster, a colossal aggregate of gravity and dark matter, was precisely what was needed to cause such a dramatic lensing effect. It was bending the light from a single, distant spiral galaxy, splitting its image and presenting it to our telescopes as two distinct yet perfectly identical entities. The light from that lone galaxy was taking two different paths around the intervening cluster, reaching us as if it originated from two separate yet identical sources. The realization was profound. Hamilton's object was not an anomaly that shattered the rules of galactic uniqueness. It was, in reality, a single, ordinary spiral galaxy, performing an extraordinary feat of optical illusion thanks to a perfectly aligned cosmic leviathan. The impossible twins were never twins at all. They were merely the spectral reflections of one. This story of Hamilton's object is a beautiful testament to the iterative nature of scientific discovery. It began with a baffling observation, one that challenged deeply held beliefs. It moved through a period of intense puzzling until an audacious theory, gravitational lensing, provided a potential pathway to understanding. And finally, through careful observation and the relentless pursuit of truth, the cosmic mirage was unveiled. It reminds us that what appears to be an exception might in fact be an intricate demonstration of a more fundamental, albeit subtle, rule of the universe. The cosmos is a vast, bewildering canvas full of such wonders and illusions. It constantly invites us to look closer, to question what we see, and to marvel at the intricate dance of light and gravity. What other cosmic mirages, do you wonder, might still be out there, waiting to be unveiled? We'd love to hear your thoughts on this incredible story. Do share them in the comments below. And if you enjoyed this journey through the cosmos, consider following for more tales from the universe's grand narrative.